Okay, hi Patricia. I am sitting in my office and I've got some other people in here with me, so if you hear some background noise, please bear with me. Dealing with a question where I was given an amount of butane, and that is the mass of butane is 1.5 grams, and I'm asked how many atoms of carbon are in there. Alright, so what I'm going to do is, first of all, as I've said before, every time I'm given an amount in chemistry, given an amount, especially if I'm given a chemical formula, I'm always going to be thinking about formula weight, right? What's the molecular mass? So the formula weight of butane, because I'm given that, I'm going to write this out before I even start mapping out a solution. I'm going to do that. Formula weight. So I go to my periodic table and I see that formula weight of a carbon is 12.011. That's grams per mole, or AMU, right? And the formula weight of hydrogen is equal to 1.008 or 794. Sort of depends on which table you're using. All right, and so I've got 4 of these, right? 4 carbons and 10 hydrogens. So I'm going to take 4 times that and 10 times that, and that's what I did here. 12.011 times 4 plus 1.00794 times 10, and I did this in advance of this video, so I could just write it in here, is equal to 58.1234 grams per mole. 58.1234 grams per mole. At this point, I'm probably going to set up my solution, but I'd like to ask a couple assumptions. I'd like to ask you some other things we can assume before we begin. 1 mole of, 1 mole of butane is going to give you how many moles of carbon atoms? And you really have to understand what this formula means before we set this up. 1 mole of butane is going to equal how many moles of carbon atoms? The answer is 4. Okay? Right? Because there's 4 carbon atoms in every 1 piece of butane. So 1 mole is going to give you 4 moles. All right, let's look at what about the next one? 1 mole of carbon atoms is going to give you how many carbon atoms? Please pause the video right here and fill that in. Okay, let me suppose you paused it and say that 1 mole of carbon atoms is Avogadro's number, 6.022 times 10 to the 23rd carbon atoms. Okay, and with these things in mind, this one's the one that I think should have been obvious from the beginning. With these things in mind, we're going to set our solution up. The question is, how many atoms? How many carbon atoms, right? And that's going to be our answer. And so we know that we're going to have carbon atoms in the question stem. And sure enough, I can relate carbon atoms to moles of carbon atoms right here, right? So this is going to be moles of carbon. All right? And that's in my answer, but there's no moles of carbon in the answer, so I've got to cross that off. Moles of carbon. And what else is carbon related to here? Moles of carbon is related to moles of butane. Moles, I'm going to say bute. Okay? These will cross off then. And there's no mole of butane in my answer, so I have to cross that off too. Moles of butane. And what is moles of butane related to? I've already related to that. It's related here to grams of butane. Grams of butane. Alright, so those will cross off. But there's no grams of butane in my answer, so I've got to cross that off too. Grams of butane. And what's that related to? Nothing. It's a measurement. So my grams of butane is given right here. Alright, so this is my solution. Now let's go ahead and put our numbers in. I want to ask you, especially if you're a little mystified by what I've done here, or you don't feel super comfortable with conversions, now would be a good time to pause the video. I'm going to point at this and say what number goes right here. Pause the video and guess what I'm going to say. What number goes with grams of butane? And you're going to look up here to find that, of course. Okay, let me suppose you paused it and find it's 1.50 grams. Okay, what number goes here? Should pause it. It's 1, right? Because we have 58.1234 grams per mole of butane. So it's 58.1234. Okay, you really maybe should pause it and put all these numbers in and see if you get the same thing I get. How many moles of carbon for every 1 mole of butane? how many moles of carbon, or how many carbon atoms per every mole of carbon atom? For every 1 mole, it's 6.022 times 10 to the 23rd. Okay, let's figure that out. 1.5 times 4 times Avogadro's number. Okay, and then divide by 58.23, and you should get a 6.216 times 10 to the 22 atoms, right? Okay, and the final thing I want to do, of course, is write this in sig figs, and then I'm going to go back and ask one final question. So how many sig figs in this number? 3. How many in this number? That's exact. How many in this number? Aha, that's also exact. There's exactly 4 carbon atoms in every mole, right? So that's an exact number. What about this number? That's not an exact number. There are 4 sig figs in that one. What about this? That's exact. Exact. It's 6. Okay? Of all these numbers, what's the least? 3 sig figs. So I'm going to have to say that this is the same thing as 6.22 times 10 to the 22 atoms of carbon. And the final thing I want to point out here is that if you get a small number here, this makes no sense. Sometimes people say 6.22 times 10 to the negative 22, and that's a very small number, that's less than 1. And you know that you cannot have less than 1 carbon atom. You cannot have less than 1 atom. Right? Why can't you have less than 1 atom? Maybe that's something we should discuss in class. You cannot have less than 1 atom. Alright, I hope that's helpful, and I appreciate the questions. Please keep them coming, and I wish you the best in your studies.